that you hear me and see the board okay? Awesome, thank you. I'm gonna get started. So guys, last week we were in section 5. We are still gonna be in section 5. We'll probably be in it all this week too. Section 5 is solving polynomial equations or functions by factoring, these higher degree equations that we have to solve. Last week, if they asked you to solve a higher degree polynomial equation, it was because they gave you a clue, right? They said x plus 3 is a factor, or they said f of 4 equals 0. Either way, all of those clues led to a round of synthetic division, and we started breaking the polynomial down that way by using the synthetic division. This week's problems, they ain't giving you a clue. Every single polynomial they ask you to solve, they expect you to be able to solve it by some type of factoring. So guys, when I tell you, you have to be on top of your factoring game this week, oh my God. You have to be a factoring master, a factoring wizard, a factoring Jedi, if you will. You have to be the best of the best right now, okay? So, I gotta kind of warn you, I know it's not good when your math teacher starts a lesson like this, but you gotta put on your big boy pants, your big girl pants today, because I'm telling you, we are doing some heavy duty math. You are expected to know what the heck I am talking about today, okay? So I'm gonna focus on 2 types of problems today for your homework. I did not make today's homework due until Wednesday night. I want you guys to have today, tomorrow, even Wednesday to make this feel good before your homework is due. Because I'm telling you, this is some heavy duty solving that we are doing, okay? And I want you guys to have time to digest that, okay? All right, here we go. Some reminders first. Number 1, the degree of the polynomial equation or function, guys, that should equal the number of roots or zeros that you get. So if it's a degree 3 polynomial, there should be 3 roots, 3 zeros, 3 answers to that problem. I love knowing that. I use it like a cheat sheet. I'm like, did I get all my answers? Well, I got 3. I should have 3. I'm good, all right? But that's also going to be a little bit, you got to be careful with that, and I'll explain it why when we're doing it, okay? Now, I also want to remind you that the roots or zeros or answers to a polynomial equation, guys, they can be real numbers or they can be imaginary numbers. Remember, when we were solving quadratics, degree 2s, if we took the square root of a negative number, we didn't get no real answer to that because no real number squared equals a negative. So there are going to be imaginary numbers that make a comeback. We may get imaginary number answers again. So please be prepared for that. All right, remember, the imaginary number I was equal to the square root of -1, right? Remember, I was the number that when you square it, it equaled -1. Okay. Now, only the real number roots or zeros. If you get real number and you get imaginary number answers to this problem, only the real number answers, the roots or zeros, can actually be called the x-intercepts. Because a graph will not cross over the x-axis at an imaginary number. So not all of your roots, zeros, or answers can be called an x-intercept. Only the real number answers that you get can you call an x-intercept, okay? Now, I say that because in the next section, where we go next, we are going to start graphing these higher degree polynomial equations or functions. And in order to do that, in order to graph them, you got to be able to find the roots, the zeros, the x-intercepts of its graph. X-intercepts play a huge role in the graph of a higher degree polynomial function, all right? Okay, so in order to find the roots, the zeros, the x-intercepts of higher degree polynomial functions, we need to be able to perform various types of factoring. Like I said, you got to be able to look at some type of polynomial and know exactly how you want to factor that. You got to be on top of your factoring game. All right, there are some pretty standard solving steps that we take to solve a polynomial equation for its roots, its zeros, its x-intercepts. We set the polynomial equation equal to 0. We factor it. And because these are such high degrees, guys, please look for a GCF. A lot of them will have a GCF. Set each factor equal to 0 and solve. And then remember, you may get real number answers and you may get imaginary number answers. But only the real number zeros and roots can be called the x-intercepts. Let's do it. Let's give it an example. Let's go. Put on those big boy pants, those big girl pants. We are ready. All right, so I worded the directions exactly how Delta Math is going to word your directions, so nothing will be surprising. All right, the directions say, find all the x-intercepts, that's important, of the given polynomial function. Express your answer as a list of x values. So at the end of this problem, we're just going to list our x-intercepts. But guys, do you notice? They didn't say solve it. They didn't say find the zeros. They didn't say find the roots. They literally said find the x-intercepts. Now, you find the x-intercepts by solving it, by finding the zeros, by finding the roots, by setting the equation equal to 0 and solving. But because they asked us for the x-intercepts, the only thing I can include as my final answer are any real number answers. I cannot include any imaginary number answers that we get as an x-intercept because only the real numbers are the x-intercepts of its graph. So it's kind of nice that if we do end up getting an imaginary number answer, we're not going to list it in the end because it's not an x-intercept, okay? It's just a root, it's just a 0. It's just an answer. All right, here we go. So guys, if you take note, we set our polynomial function equal to 0. Our job is to solve it. They have not given us a clue, so they expect us to be able to factor this on our own. Guys, it's a degree 4. So if you know, a degree 4 polynomial should have 4 roots, zeros, answers at the end. However, if any of those 4 zeros or roots are imaginary numbers, we will not include them as a list of x-intercepts, okay? All right. Well, if we have to solve this degree 4 polynomial, let's hope and pray that there's a GCF, guys. Let's hope there's something smaller, or I'm sorry, something we can take out of this to make it a smaller and easier polynomial to work with. All right, let's look at it. Does anybody know what a 3, a 27, and a 30 have in common? A 3. And since it leads with a negative, let's take out the negative as well. So we're taking out a negative 3. Let's see if they have any variables in common. This one has an x to the 4th, this one has an x to the 3rd, and this one has an x squared. That means he's got 4 x's, he's got 3, and he's got 2. It means that all of them have at least how many x's in common? 2. They all have at least 2, right? They all have 1, but they all have at least 2. All right? So that means we can take out an x squared. If you remember, the variable is always the littlest variable there. That's what they'll have in common. All right, so guys, take it out. If negative 3x squared is their greatest common factor, let's take it out and show what polynomial is left. So if you remember, we used to do this. Negative 3x squared times what gets you back to a negative 3x to the 4th? A 1x squared. Negative 3x squared times what gets you back to a positive 27x to the 3rd? That would be a positive 9, I'm sorry, negative 9x. And then a negative 3x squared times what gets you back to a positive 30x squared? A minus 10. Beautiful. Okay. And then if you remember, once you take a GCF out, you're supposed to look at your new polynomial to see if you can factor it again. Guys, this looks like a pretty standard 3-term quadratic that we should be able to factor. Let's see if we can factor it again. All right, so we know whatever we put in the first 2 spots has to multiply to x squared. Who do we always use for that? X. I know whatever numbers I put in the last 2 spots have to multiply to negative 10, and then my rainbows have to add up to the negative 9x's in the middle. Well, guys, if we're multiplying to 10, you got 2 options, 1 and 10 or 2 and 5. It looks like 1 and 10 are going to be the ones that get us that negative 9. So in any order, I need a 1 and a 10. And now what signs do I need to multiply to that negative and then add up to that negative 9x? I would need a minus 10 and a plus 1. Now, I'm not going through all the factoring motions exactly because you guys should know what I'm talking about. You should know what I'm doing when I say this, okay? All right, and then most importantly, for the love of God, please don't forget to bring down your original GCF because he's still one of the factors. Okay, guys, we did it. So we factored it. If you multiplied all this back together, we would get the original polynomial. We don't want to do that. But since we factored it, we're now saying that this times this has to equal 0. The only way that could be true is if somebody was 0. But it could be any one of these factors who ends up being 0. So now we just set each factor equal to 0 and solve. So we're going to take this factor, set it equal to 0, and solve. So guys, you are solving a little mini quadratic equation. How many answers should I get to this? You should get 2 answers from this. And watch. I'm going to divide the -3 away because we learned how to solve using square roots. And it says to get x squared by itself. And now we have x squared equals 0, right? Okay. Before we solve this, can everybody look at this? Guys, if it didn't say x squared equals 0, what if it said this? If it said x squared equals 4, what number could you have squared to equal 4? I could have squared 2, but I also could have squared. What other number do you square and get 4? -2. I could have gotten -2. So this has 2 answers. When I take the square root of both sides, when you take the square root of a square, they cancel. But when you take the square root of a square, it leaves you with 2 answers, the positive and the negative version of that. Do you guys remember getting that plus or minus? You should. So you should get 2 answers to a quadratic equation. And we get it by saying that plus or minus 2. All right. Well, now, the thing is, you're going to take the square root of both sides, so they cancel. X equals. When I take the square root of a square, it should leave 2 versions of that, the positive and the negative. But guys, what's the square root of 0? It's 0. And there's really no such thing as positive or negative 0. But for anybody who's keeping track and wants to be counting 4 answers to this degree 4 polynomial, just know you really did get 2 answers right here. You got x equals positive 0 and you got x equals negative 0. There really is no such thing. It really is just x equals 0. But again, if you're going to count and keep track, you did just get 2 answers here. Now, I like to think of it like this. I don't mean to harp on this, but it's very important. If you go back to this statement, where we had to solve x squared equals 0. Instead of using square roots, you could have done this. X squared is x times x, right? So now, set this factor equal to 0, I get x equals 0. Set that factor equal to 0, I get x equals 0. And you get 2 answers from one equation. It's the same answer twice, which is fine, but I get 2 answers. Because if you want to be able to count, you got to know that you just got 2 answers from this, okay? All right, then we're going to set this factor equal to 0, and I get x equals -1. That's nice and easy. And then I'm going to set this factor equal to 0, and I get x equals 10. So my degree 4 polynomial should have 4 roots, zeros, or answers, and it does. 1, 2, 3, 4, because he does count as 2 answers. I got 2 answers when I solved this. It just happened to be the same answer twice. All right, now, they didn't ask for the roots or the zeros. They asked for the x-intercepts. So now you would just go through. Any real number answers you got are going to be the x-intercepts. Well, guys, the good news is we only got real number answers. So that means all of these get to become the x-intercepts. So on Delta Math, it's going to have you list the x-intercepts, right? So you would list in any order, 0, but you don't have to list it twice. You don't have to list it repeated. Just list it once, even though you did get 2 answers from that. And then -1, and then 10. And that's what you would type into Delta Math. Those are your x-intercepts of his graph. His graph will cross the x-axis at 0, -1, and 10. Okay? All right. So again, the number of answers that you get, 4 should equal 4. But it doesn't mean the number of x-intercepts you write down might look like 4, okay? All right, let's try the next one. Let's try this type one more time. All right? Were you guys okay with that? Everybody here? Yes? Guys at home, can I get a thumbs up? Are we okay? Hanging in? Good job. I saw you thumbs. Okay.
I think there's people there. I'm not really sure.
I see a lot of ceilings.
Oh, there's Michael. I can see what's pretty on it.
Okay, I don't see everybody on my screen is the problem.
Oh, okay.
All right, so here we go. Let's do it again. So notice the directions. Find all the x-intercepts. Well, you find the x-intercepts, guys, by finding the zeros and the roots. So we're going to set our equation equal to 0 and solve. But remember, Only the real number answers that we get can actually be the x-intercepts. All right, guys, this is a degree 3 polynomial. So a degree 3, at the end of the day, when we solve it, it should have 3 roots, 3 zeros, 3 answers. But that doesn't mean that all 3 of them can be an x-intercept, because if any of those 3 answers are imaginaries, they can't be an x-intercept. All right, here we go. Well, like always, let's look for a GCF first. They didn't give me a clue. Let's try and break this down by looking for a GCF. What does a 45, a 60, and a 20 have in common? 5, and let's make it negative because it led with a negative. And then does anybody know what an x to the third, an x squared, and an x all have in common? They all have at least 1x. So take out an x. All right, what's left? If I take a negative 5x out of all these terms, who's left? Negative 5x times what gets you back to a negative 45x to the third? A 9x squared. Negative 5x times what gets you back to a negative 60x squared? A positive 12x. And then a negative 5x times what gets you back to a negative 20x? A positive 4. Okay, and like always, once you take a GCF out, let's try to factor that new polynomial again. Guys, that new polynomial looks like a normal 1, 2, 3 term quadratic that we should be able to factor. So let's give it a go. Let's try to factor this again. Okay, I know whatever I put in the first 2 spots has to multiply to 9x squared. It's a little bit of an issue. Maybe it's 9x, 1x. Maybe it's 3x, 3x. You guys have to work your rainbows, work your magic until you found them. To save time, I'm going to tell you it's 3x, 3x. All right, and then we know whatever number we put here and whatever number we put here, they better multiply to 4. And then my rainbows better add up to those 12x's, right? So the only numbers I could put here that multiply to 4 are 1 and 4 or 2 and 2. And then you would work the rainbows. Who gets the job done, right? I'm going to tell you to save time, it's 2 and 2. But you should know how to get that on your own. It takes a little guessing and checking, and then you got to figure out your signs. How do I multiply to a positive 4 and then add up to a positive 12? Well, guys, normally the rule is if everything's positive, then you need positives. All right, and then I can show you that it still works. 3x times 3x is 9x squared. 2 times 2 is 4. That would get me 6x's, 6x's, total add up to 12x's. It's our guy. All right, and then please don't forget, bring your original GCF down. Okay, so we factored it. Now we just set our factors equal to 0 and solve. And you should get 3 roots, 3 zeros, 3 answers. However, they have to be real numbers for us to call them our x-intercepts. All right, so if I take this one, set it equal to 0, divide by negative 5, and you get x equals 0. So 0 is one of our roots, zeros. And since he's real, he's definitely an x-intercept. All right, let's take this factor, set it equal to 0. I got a little bit of work to do. I'm going to minus 2, start getting x by itself, and then I'm going to divide by 3, and I'll get x equals negative 2/3. That's a real number, so that is an answer, and that is definitely an x-intercept because it's a real number, root, 0, or answer. And then guys, I don't know if you noticed, but we did get the same factor twice. So you're going to end up setting the same thing equal to 0 again, and you're going to get the exact same answer twice. That's okay. I'm going to get minus the 2, divide by 3, and I get x equals negative 2/3 again. So for anybody who likes to keep track, yes, this was a degree 3. You should have 3 answers, 3 roots, 3 zeros, and you do. 1, 2, 3. It just so happens that one of them was the same answer twice, okay? But it does count as 3 total answers. Now, it didn't ask for the roots of the zeros. It asked for the x-intercepts. So all we do is keep any real number answer that we just got. 0 is real, and negative 2/3 is real, but we only have to list them once as our x-intercept. So our x-intercepts in any order on Delta Math, you would list 0 and negative 2/3. And again, you don't have to list it twice. So the number of x-intercepts might not match that. That's what I'm trying to show you, so just be careful. How do we feel? Are we okay? Because like I said, these are as easy as our homework problems are going to be. It's take out a GCF, and then you have standard factoring of a quadratic, okay? All right, let me show you the third example, and then I'm pretty sure the bell's gonna cut me off, and then I won't be able to do the fourth one. But the third one is gonna bring back factor by grouping, if you remember when I taught you about factor by grouping. And then this will be the only other kind of homework problem. It's the first two, and then this time our homework that is due Wednesday, just two types of problems. All right, we're gonna work for this one, guys. Look at this. Okay, like before, the directions say to find all the x-intercepts of the polynomial function. Again, to find the x-intercepts, you have to find the roots, the zeros, the answers. So we have to set this equal to 0 and sum. But only the real number answers can we say are x-intercepts. All right, guys, we got a degree 5. We should have 5 answers. This is nuts. So we're at a degree 5. So we should have 5 roots or zeros or answers. But remember, if any of those 5 answers are imaginary, they will not count as an x-intercept. So it doesn't mean I'm going to have 5 x-intercepts necessarily. All right, here we go. Guys, I'm going to hope and pray for a GCF. This is a degree 5. What does a 1, a 7, a 1, and a 7 have in common? Technically nothing, right? Or 1. But we don't always factor out a GCF of 1 right now because it wouldn't change anything if I pulled out a 1. All right, but then what does an x to the 5th, an x to the 4th, an x third, and an x squared have in common? X squared. An x squared. So we can at least take out a 1x squared. So take out an x squared. And then all you got to do is take 2 x's out of each term. So then he would be a 1x to the 3rd. He would be a minus 7x squared. He would be a plus 1x. And he would just be a minus 7 because you took his 2 x's out. All right, now, once we take a GCF out, we're supposed to look at the new polynomial and try to factor it again. But guys, hold the phone. We were not left with a normal 1, 2, 3-piece quadratic that we know how to factor. We were left with a 1, 2, 3, 4-term degree 3 polynomial. The only thing I have taught you that might be able to factor this is factor by grouping. So we have to try factor by grouping. And this can be a little hard on your eyes. So guys, when we factor this by grouping, I need everybody to pretend this GCF is not here. Please try to ignore it because it can get in the way and it can make this confusing. If we're going to factor this by grouping, if you guys remember factor by grouping, to factor this by grouping, you group the first 2 terms together, make a group, and then you group the second 2 terms together and make a group. Then you're going to look for the first group's GCF. What does an x to the 3rd and a 7x squared have in common? X squared. An x squared. Take it out. And then what would be left out of these 2 terms if you took an x squared out? X squared times what gets you back to x to the 3rd? X squared times what gets you back to negative 7x squared? Minus 7. Okay. Then you go to the second group. The second group, there's a rule that says you have to pull the leading sign out no matter what. So since the second group led with a plus, I have to pull out a plus. If the second group led with a negative, I would have pulled out a negative. All right, now you have to find the second group's GCF. What does an x and a 7 have in common? A 1, right? Guys, you could say they don't have anything in common. You're right, but everything has a 1 in common. And since I have to pull something out here, you got to at least make it a 1. So plus 1. Now, if you pull out a positive 1, nothing should have changed. Positive 1 times what gets you back to x? X. Positive 1 times what gets you back to negative 7? Negative 7. Okay. Well, guys, if you remember, factor by grouping only worked if you were left with this matching factor, this matching parenthesis. And we were. X minus 7, X minus 7. So that means we're ready to write our factors. One factor is always the parenthesis that matched. So X minus 7. Your second factor was always made up of who did you factor out? I factored out an X squared and a plus 1. So that made up the second factor, and you're done. Okay, now, that was the factor by grouping, right? That factored this. But now you gotta remember to bring your original x squared GCF down. So don't forget to bring your original x squared GCF down. Is everybody okay with what just happened? Yes? Okay. So this is set equal to 0. Let me just rewrite it up here. Now that we factored it, we start setting our factors equal to 0 and solving. All right, so set this guy equal to 0. X squared equals 0. Guys, that's a quadratic. You should get 2 answers from that. Whether you want to think of it as, take the square root, and x equals plus or minus 0, which is really just 0. But guys, you got 2 answers from that. You did get 2 if you're trying to keep track. All right, and then take this one, set it equal to 0, and you get x equals 7. Guys, take this one, set it equal to 0, and solve. We're going to minus 1. It's a degree 2, so we should get 2 answers. Square root both sides. X equals, if I take the square root of a square, I should get how many answers? 2, plus or minus. Guys, just took the square root of a negative number. That answer is definitely going to be imaginary, but it's an easy one. So actually, anybody remember who the square root of -1 actually was? He was the imaginary number I. So it's plus or minus I. So your answers, roots or zeros, all 5 of them are 1, 2, 3, 4, 5. You did get 5. But they didn't ask for the roots of the zeros. They asked for the x-intercepts. So the x-intercepts are only the real number answers you got. So the x-intercepts are, well, they're out. You can't call them x-intercepts. I would say 7, and I would say 0. And I don't have to list this more than once. It's just 0 and 7. So you really only show 2 x-intercepts to this degree 5 polynomial. So that can be confusing. How did that feel? Are we okay? I know. All right, so listen. I would have loved to be able to get to this one, but it just takes too much time. I am going to have it filled in on the notes on Google Classroom if you want to take a peek at it, if you start the homework tonight, because it might help you, all right? Otherwise, like I said, your homework is not due till Wednesday. We're going to do this again tomorrow. Believe it or not, I still have a little more I have to add to it. I know, I'm sorry. All right, but that's it. You have plenty of time to start working, okay? Let me take, is the attendance good at home? All right. All right, guys, at home, you are going to be good to go. Please, guys, I get it. This can be hard. You have to communicate with us if you are struggling. Please reach out to me if you are struggling. All right, otherwise, you are good to go. Have a wonderful